Yes, unfortunately. But all right, welcome back, guys. Today is the ultimate day for 4.6. Now, when we graph sine and cosine, what's the biggest it ever gets? One, right? Sine or cosine. Cosine gets positive one all the way at 0. Sine gets to 1 up here, but they neither of them get bigger than 1. What's the smallest that either of them get? Unless we put a number out in front, right? If we change the amplitude. Now, what we're going to look at today is only a couple small examples, and they take some practice, but it's the last little part of 4.6. And we're going to be looking at what we call damped, which we're going to stop right there. It does not mean to be made like damp, like wet, humid type stuff. Anybody in here have a wood-burning fireplace at their house? You burn wood. Okay, if I want my fireplace to burn hotter, there's usually something that I pull out. Do you know what that thing is called? You could call it a vent, but there's another word that's commonly used. It's called a damper. Yeah. A damper is what's used because I push it in and it lets less air into the fire, which means that chemical reaction happens slower, right? Less fuel. Or I let more air in, and all of a sudden there's way more reactants and more fire and heat reaction going on. We're going to do the same thing, but instead of dampening a fire or a chemical reaction, we're going to damp some trig functions. So here we go. Now, what this really comes down to is, can I graph x? Like, I know how to graph y equals x, and I think you guys do. If I said graph g of x is 2x plus 1, could you guys also graph that? And I'll write these down, but it's in pink just to think. You know what? I lied. I'll just do them here. So we're just going to make a couple notes. We can graph. And we won't like construct each individual graph, but I think I could do h of x, and I just want some confirmation. Can you guys graph this? What's the y-intercept of that function? 0. What's the slope of that linear function? Awesome. We could graph that. Deal. Can we all graph this? I think so. Now, here's what's fun. When we're looking at these are just two normal functions, right? It's a linear, and it's called transcendental because it transcends or rises above just regular algebra stuff, but not our focus. What we're going to be looking at, if we shove these together, the product, and we'll just write this out. If I multiplied h and g here, I'm going to call it f of x, which is just found by taking h of x times g of x, can be graphed also. Now, as we look at this, it takes a little bit of thought, and we will be making at least a small table, but we can graph this also. And it's going to have an impact on my graph. In this situation, we're just going to build into it, but we're going to talk out some of the specifics just as we go, so that way more talking in hopes of stirring questions and stuff. Okay, we're going to graph this product is what we're going to do. So let's try it and see what happens. Example, and we're going to graph, and we'll define it f of x again, and I guess we'll do this one on a. Let's do f of x is equal to, well, if I did h times g here, what would it be? And it, like, you're going to be right. Davian, what's h? H of x, rather, sorry. So that I would say that was g. What's h? It's just x, right? Times the sine of x. So this is really what we're graphing. Okay, here's where we get kind of wonky with it. I'm going to make a few notes here. Everything here is going to be orange, so it's entirely up to you. Normally, sine gets as big as 1, right? So if I went to, and we're just thinking out some values, does this function get bigger than 1? Because where is sine 1? Just to check our unit circle stuff. We'll make a few observations. Note, when x equals, and when is sine 1? Pi halves. And we'll put all this on a table as well, but we're going to do some wordier stuff. When x equals pi halves, we have the following. And normally, sine would just be up to 1. But now it's being multiplied by something out in front, right? And we can't just call it an amplitude because it's not a constant. It's going to change as we go. But let's see what happens here. If we did pi halves times the sine of pi halves, what would we get? This is pi halves, and I'm just taking this one, times what? No. Okay, good day. What's that value again? 1. So when I actually do this, I get pi halves instead, right? Now, if I call pi 3 for simplicity's sake, this value is already like 1.5. It's really like 1.57. But all of a sudden, this function got bigger than 1, right? So it's been given more fuel, it's gotten bigger because it's just been made bigger and bigger. If I pick an obnoxiously large value, like 50 periods away, does it get bigger and bigger still? Because if I plug in 100 or 200 pi, what? I'm trying to work this out. Well, it's at 100 full circles, which is 50 pi. If I do 51 pi over 2, I now have 51 pi over 2 times 1. It just keeps getting bigger and bigger. There's something wonky that happens, though, because I see that's going to happen as I go further and further in the x direction. X keeps getting bigger, so x times the sine of it eventually gets bigger and bigger and bigger. What if we go the other direction? So you think so? Well, let's try. Let's go to, I don't know, negative pi halves. And I want you to do the same thing. Evaluate what this function f of x would be if we were at negative pi halves. So I'll start it, but I'm going to make you guys finish it for me. Negative pi halves times the sine of negative pi halves. And whoever said bigger, I love that you're giving me stuff, but I want you to tell me that you were right. What does this give me? Negative. So careful, because what sine of negative pi halves? Straight down, right? So here we're at 0, and we go straight down to negative pi halves. Negative 1. So this is back to pi halves, right? So we see some wonky things happening right off the bat. Now, ultimately, and we're going to summarize this, what is truly happening, because I have sine that changes from being a positive value to a negative value throughout the circle, instead of just being stuck in this line, which is y equals x, instead of just being stuck there, we have to consider the part where sine is negative and x is positive, or x is negative and sine is positive. So we get both sides of it. We wind up being stuck between two different things. The graph is stuck between, well, on one end, it's y equals x, because that's as big as it can get. If x is positive and sine happens to be positive there, this is the biggest possible value. Largest, if both positive. Now, it would also be the same if x and sine x were both negative. It would also be big, or both negative. And when I'm saying both here, and I'll wait till you guys are done writing. When I'm saying both, I'm specifically referring to x and to the sine of x. If both are positive, it gets bigger than 1. If the numbers are big enough. If they're both negative, because it's a negative times a negative, it's still going to get bigger. So these are my big values. But I also have to consider the small side of stuff. It's stuck between y equals x, and we'll put this on a graph here in a minute, and, well, is it possible that x is positive, but sine of that angle is a negative? So it might get as small or as negative x. Okay, so it's stuck between these two things, between x and negative x. And we'll play around with this to make some more sense of it. Does anybody look at this and go, Holloway, I don't understand a single thing that we've written, and you've been talking for like 5 minutes? Okay, would love it if you would give me that heads up like 5 minutes ago, but let's graph this real quick. Let's like construct it and see if we can make sense of it, and then we'll ask the same question. But I want honesty. Don't just tell me yes because that's what I want to hear. We're going to make it so that it's a true yes. Okay, so let's start building a table and just kind of play around with this. And our table is going to be big, just so you guys know, like more than 5 points right now. And we'll just see how big. Since it's going to be a fairly large table, what I would suggest, let's just commit to, we'll draw a graph like over here, and we'll make a big vertical table because that's more normal. X times the sine of x, and we named it f, right? Okay, so I would not draw the true size until we're done because we're going to be able to see what's happening pretty quickly. Instead of starting at 0, though, I want to consider what happens when we center 0 in the middle. And we'll see this exact thing happening. So let's pick 0. And we can do all these points out, or we can just pick some values and assign stuff to people. We'll do the first few together. Okay, at 0, what does this turn into? 0 times, what's the sign of 0? And what's 0 times 0? All right, so I have a point on my graph. Now, there's no real preference in my mind of which way we go. Do you want to get all the points and then put them on the graph, or do you want to get a point and then put it on the graph, and then get a point and put it on the graph? Get all of them? Okay. So give me a positive x value and make it nice. Pi halves is a nice one. I agree with you. And we already did this, but we'll just double check it. Pi halves times, what's the sign of pi halves? 1. Says all of a sudden this thing goes up to pi halves. Now we're going to get really easy values for this every time. Let's just try to pick the standard points and see what happens on a couple periods of it. So we'll do 2 periods, 1 positive, 1 negative is what I'm going to commit to. What's pi? Pi times, what's the sign of pi? 0, right? I'm over here at pi. The y value at this ordered pair is 0. Okay? So pi times 0 is, now that's normal. That's what I expect to happen with sine. Ready to get weird? Good. Good. I want you to do 3 pi halves and 2 pi for me. And then while you're at it, you might as well do negative pi halves, negative pi, negative 3 pi halves. And then we're going to divvy this up a little bit. And negative 2 pi. Davian, Wisha, Addison, and Krina, I want you guys to start with these 3. Everybody else do that, that, and that. Those 3. Let's divvy up the labor. So you 3, 4 are doing these ones. And if you need help, just let me know and I can help you with it. But we'll give us a minute. I'm going to pause the video because it's just going to be awkward silence if I don't. Oh, did I tell you the funny joke that I made about your classmate? So Abijah, okay, let's graph this thing together. And by that, it's always strange. But I see that my values get bigger and bigger and bigger. And I'll probably use some decimal approximations for these, just so you guys know. But I'll grab my calculator here in a second. So let's see. Here's our graph. We have the x-axis and we have the y-axis. Now, just in the interest of stuff, I'm going to jump. We'll say here's pi and here's 2 pi. And we'll put the little half ticks on so it's easy to graph. And then that means that half tick and negative pi. And it looks like I'm not going to go quite all the way on my scale. Oh, I'll be pretty close. That looks square to you guys? That last one looks a little shorter. We'll be okay. All right. Now, here's where I am going to approximate. I'm going to put these numbers here. Calculators, some of you guys have them. Pi halves is roughly 1.57. So I know that that's going to be like 1.57. And then, I don't know, 3 pi halves. Addison, can you check on that calculator for me? And I'm trying to remember where 3 pi halves. I just don't know the decimal. On that calculator, that's a good question. I don't remember. Hiding somewhere. You found it? Good. 3 pi halves. It's roughly 4.71. Okay. Now, only reason I'm using these is to help me pick a scale right here. Oh, I guess maybe I don't need that. What's a better choice of a scale than ugly decimals? Let's just use the numbers. What am I doing? So here's pi halves. I don't know what I was thinking. I'm sorry, guys. Which means that's pi, and that's 3 pi halves. What am I doing? Yeah, sorry. That's a much better choice. Cool. I'm just going to start plotting these points. Now, we're going to see there's sort of some wonky stuff that happens, but we'll deal with it. So let's go. I know that I get 0, 0, and I get pi 0, and I get 2 pi 0. So those are nice. I'm going to just get all those ones. And then here's where we start to see this dampening happening. Because right now it just kind of looks like normal sine function. I just haven't drawn it yet. Okay, well, let's just start checking. At pi halves, it's at pi halves. And then at 3 pi halves, it went down to negative 3 pi halves. So right off the bat, when I'm putting these points in, and we're going to check it here, I'm going to do these other points. I have these points right now. And I don't think I have any mistakes. Pretty sure of it. Okay. As we start looking at it, and I'm going to wait till I see everybody have points done because I'm going to draw and talk specifically like as I'm drawing things. Does it feel similar to sine? Kind of. Now, here's what I see happening. This first part, it's weird that it goes up to pi halves, but it still feels like sine. It feels like a wave. And it comes down as I would expect. Now, here's where the dampening is happening. Is this function allowed to get bigger than it normally does, or is it getting smaller than it normally does? So you say smaller, why? How big is it normally right here? It's normal. So real sine is normally 1. So I'm already bigger. And then beyond that, it seems like the amplitude is just constantly changing, right? It's getting taller and taller as it waves, which makes sense because we have this thing in front of it. Now, what winds up happening, and I'm going to do this other side, is there's some wonkiness that happens in here if we think out one small angle. Like, I'm just going to say, let's think about negative pi 6, because that one's easy. At negative pi 6, which is like right here, what is the sine value? Positive or negative? So here we are at 0, negative pi 6. Sine is negative, right? And now I'm going to multiply it by a negative, so it's going to give me a... So I know it doesn't just pass through the origin like it normally would here. Instead, it does something like this. And I'm going to make this look a little bit nicer. My scale's not perfect, is why it's all weird. Or that point is actually just kind of far off. There we go. And all of a sudden, does it still kind of look like sine? But it's waving bigger and bigger. And I'm going to draw it into my table here. If I went further, is it going to go higher than this? Is it going to go further up than that distance? In fact, it's going to go up the same distance, right? Like on our next period, it's going to go up like this, and it's going to come down like this. It's just going to keep getting bigger and bigger and bigger. And I can see that's happening. Now, right now, this statement still probably doesn't mean anything, but it's about to. Could I graph the line y equals x fairly easily? And I know that y equals x will pass through this point, I think. And it'll pass through this point. And it's just anywhere that x and y are the same. It's the same, right? So I think it's going to pass through these points. And my graph isn't perfect. But I also see the negative side, it looks like it's going to be stuck between those. When we were looking before saying, oh yeah, it's just going to be between these two things. And let's just review. We said it's between y equals x, which is here, which it's not perfect, but does it look like it's kind of stuck underneath that? Or between this line and the x-axis? Does it look like it's also stuck between this line and the x-axis? So there's the positive x and the negative x part. We have a very small section of this graph. And Desmos likes to try to freak out and freeze a little bit, but I do want to see this on Desmos. So let's see if we can't crash the school network. That's a joke. I don't really want to crash the network, just for full disclosure. Okay, if we want to graph y equals x sine x, is that what our graph looked like just now? Now, here's where it gets wonky. If I keep going out, it just keeps getting bigger and bigger and bigger. It does kind of look like a bow tie, but what I really want to focus on is, I mean, yes, and I agree, and that's awesome. But if we look at like a pretty zoomed out section here, it certainly seems like there is a diagonal line that they're all stuck under, right? What was our amplitude, quote unquote, that we dampened by? Y equals what? So if I just graph y equals x, and my graph is nicer because I'm doing it on a computer, do you guys agree that it's always less than that, or between that and the x-axis? So it's been damped. It's been stuck between these values. Normally they don't exist, and it's just a 1 out in front. So it's dampened by that number. What's the other line here? Y equals negative x. And if we do this and we're correct, we should see that that line meets up with all of them. And look at that. It does. We are just sticking this function between them. Now, with that in mind, if I wanted you guys, and we're going to think about this a different way, we're going to do sketch one more, but we're going to completely flip the way that we did this. Like that problem, it's kind of ugly. Is it doable? Now, what I don't like is this little section in here, and I'm going to see if I can zoom in, because it's hard to see. Like mine crossed over. It doesn't really. And if I zoom in, I can see it doesn't really. I just drew a bad wave. It wasn't wavy enough, was all that my issue was. Okay. I want us to try to graph one more, and I'm going to turn this off real quick, and I'll make sure that people can see it. Up to you if you want to graph this like on your actual notes. I'm okay with just talking about it if you guys are, as long as we can make the sense of it, because the actual building the table part's not crazy. What if I changed it to that? X squared sine x. What is my function going to be stuck in between? If they're both positive, it's going to be stuck underneath this in the x-axis, the upward parabola. Is x squared ever going to be positive or negative? No, but sometimes is sine negative. So I think that sometimes their product will be negative and it'll look kind of like that. So let's just check. If I graph this, let me zoom out. Does it look like it did what you thought it was going to do? But I bet it will. Our scale is wonky. If we turn on the graph of x squared, look at what it's doing. Exactly like it did last time. Sorry? Now it just sits between that parabola and the x-axis. It's been dampened by this. What do you think this one's going to be? It's obvious now. And just before I turn it on, it's hard to see kind of, but if you only look at these points here and here, I bet it forms a parabola, and I'm pretty sure it's going to. It's just stuck between the x-axis and the positive and negative version. Now, if we did it with cosine, does anything change? Like literally anything, do you think? Instead of 0, like this is a weird situation, this graph starts at 0, 0. Will cosine start at 0, 0 here? Let's think it out. What's 0 squared? That's x squared. Times the cosine of 0 is 1. What's 0 times 1 going to give me? So it is weird because it tweaks everything. But if we make this cosine, it happens to start at 0 as well. And I'll put the other one back up just so we can see both of them. We are still stuck between those parabolas, but we have to adjust. And that's the hardest part, is being able to adjust. My honest advice. Yep, and now it gets a little bit too much to look at. My honest advice is if I was asked to graph any of these functions, so like y equals, and you don't have to graph this, I just want to talk this out, root x times the sine of x. That's kind of gross, right? Do you guys recall what root x looks like? Well, let's try to build it, and we're just going to build a table in our heads. 0. What's the square root of 0? 0. And then the next number is 1. What's the square root of 1? And the square root of 4? So the square root looks like this. It's not an exponential, but it looks like that. And the negative square root would then look like this. Can I imagine a function that's stuck between those parabolas? Now, it can be hard to envision exactly what it does, and I struggle with it. Like, for example, if I pick some small value like pi thirds, I don't know the square root of pi thirds, right? I have no idea. But let's just check. If I try to make this the square root of x, square root of x times sine x. And we'll just turn all these other ones off. It only exists on the positive side. Why? Yeah, this is not defined if it's less than 0, right? So automatically I see, okay, my domain has been stuck. And then it just kind of looks like it just waves and gets a little bit stronger as it goes, right? Now it keeps getting bigger. What graphs do you think I could draw that'll fit the tops of those curves perfectly? So a turned parabola, or y equals the positive and the negative. Oh, it doesn't do it. Lame. So this is going to be weird. X equals y squared. It gives me both of them. And look at it. It is exactly stuck between there, as we would expect. Somebody already came and took a photo. Hold on. Big, important ideas. Big ideas everywhere. Huge ideas. All right. Cool. People are going to think I'm just Yep, I heard it. All right. For today, they can't hear me. I have a friend that I play video games with that every night when we're playing, whenever, and it's happened for like the last 20 years, I'll always take my headset and I'll go just to be obnoxious. Good. I'm glad we're on the same page. You get some homework and 15 minutes to begin working on it. Then I'm going to pass back some papers, but I'm going to have a really hard time finding whose is whose because somebody forgot their name on their paper. I'm not saying any names. All right. I don't think it was you this time. Sure. Yes, I know you did because you sent me the pictures of the first one, and yes, I will take a look. Just for due diligence sake, I'm confident it's done. But today is the 3rd of February, and by the way, if you didn't recall, 6 more weeks of winter. We might get some freezing fog this week.
No.
So what do you think it means? Do you know what fog is? And if you would think snow, right? So there's a weird little nice point where the dew point is low enough that fog can still happen, but it's cold enough to freeze once it condensates on stuff. So depending on how foggy it is, we might get some pretty thick ice layers on top of stuff. Yep. Cool. Yeah, it happened while you guys were gone, and Mrs. Holloway said this always happens. I can only think of one day in my one time that it was foggy and below 32 degrees Fahrenheit. It was 2 weeks ago. It normally is not foggy and cold. It can be 35 and foggy, that's fine. But the other one's weird. Anyway, I want you guys to do homework 4.6.3, which you will find waiting for you on page 317. And we're going to do 1314. And I'm going to shorten this assignment. 13 and 14. Should not have licked my fingers with everybody sick. Poor choice. Poor choice. 25. 37, I want you to try. And I am cutting a lot of these, I promise. I know that it might not seem like it. I'm just trying to decide which ones I want to keep. Ooh. We did logs in here, right? Perfect. 73. It's actually E instead of a log, but okay, reminder, if you would please, on this assignment, please put on the top of it, do 2/4. So that I'm changing my late policy if we haven't reviewed that. 1 day late, not from absences late, but 1 day late will be 1 point off the fully done assignment. All right, you cool cats and kittens get 10 minutes to work on stuff. I'll let you get to it. Have fun with them damp trig functions. Yes, and then let me finish this real quick so I can So there's a weird little thing with it that we'll talk about. I don't think you'll have time just at lunch, just so you know. I it's gonna be what? Do you listen to music while you do stuff normally? You can bring, like, if you don't want to, that's fine. I can have you work somewhere. But why it gets weird is in class, everybody did it independently for like 25 minutes or 30 minutes. And then after that time, I said, if you would like to team up with somebody, no open notes or anything, but if you want to work with a partner a little bit, you can. So if Abijah is well tomorrow and here, I think that it'd be best if you guys were doing it together. But if she's not here because she's sick or whatever, like, don't try to pressure her into coming to school. I will be your springboard to bounce ideas off of if I have to. Cool. Okay. Yeah. Like that's yeah. See, I just said I was gonna stop the video so that we could have that, and then I did it all.